Hello, here's Margret Sibylle Engel, and today we will talk about detection and classification of sound marks and special features in urban areas. Murray Schafer developed the first taxonomy defined for the classification of sound sources at the end of the 70s. There, the terms keynote sounds, sound signals, and sound marks appeared. Keynote sounds are not listened consciously; they influence on our behavior and moods and are related to geography, climate, and natural sounds. Sound signals are foreground sounds listened consciously and are code-permitting sounds. Sound marks are unique community sounds, special sound qualities, and are perceived by people in a community. The aim of this study is to define new sound source classifiers and apply the suggested taxonomy to perceived sound sources in Aachen, Germany, taking into account special features. Additionally, other sound qualities, acoustic and psychoacoustic indicators, and sociocultural characteristics of the respondents are analyzed. The study design counted with a literature review that screened initially 2,580 papers, and after exclusion process and analyzing the content of the papers, we could summarize the relevance of the information in 14 papers. The data collection happened through sound walks in 3 evaluation spots in each study area. We had 8 study areas. There we collected also acoustic data, and we analyzed in the post-processing the subjective data, considering the classifiers that we found out in the literature review, and also we could also do the psychoacoustic calculation from the acoustic data. Afterwards, we made a cluster analysis, and if the clusters were significant, they generated a cluster membership that could also help in the psychoacoustic data analysis. As informed, we had 8 study areas. In most of the study areas, we had 30 participants, with exception in Elizabrunnen, where we had 44 participants. The acoustic data was collected during 15 minutes with the help of an Sennheiser omnidirectional microphone and a binaural set, together with a multi-track recording device that everything was previously calibrated. The sampling rate was 44.1 kilohertz. Afterwards, we used Artemis suite to calculate the sound pressure level in A, loudness, average, and N5, sharpness, roughness, fluctuation strength, and tonality. The questions were presented in a table where the participant could inform up to 4 sound sources, and additional questions were asked, like background sound, if it was a single event or foreground sound, also some sound qualities, if they generated emotions and memories, and if they were a special feature in Aachen. This was the main question for this study. If the answer was yes, we analyzed further the data about the sound source. The literature review showed that Schafer was classifying keynote sounds as geography and climate-related sound sources. Others authors they informed also that is a background sound, most important sound of a place. Man-made sound is also a natural sound. As examples, we have factory sounds, road noise, and fountain. Sound signals are regarding two signals, foreground sounds and acoustic warning, according to Schafer. For other authors, it is a one-off, unexpected, unpredictable, intermittent sound that inform about event or activity, is possible to do identification, alert, is code permitting, message kind of sound, is transmitted quickly and clearly. Examples are church bells, azans, and clock or time. Soundmarks are community sounds that are unique, archetypal sounds. For Schaffer. For other authors, is a sound that is regarding to time, human-made sound, active sound, less irritating, has the capacity of being noticed, give sense made of a sign. As examples, we have the fairy horn in Canada and the Big Ben in London. The post-processing, we analyze all the data collected in these 8 study areas, and we had like 3,048 sound sources, which 384 were classified as special features. From these 384, we had most of them in the topic keynote sounds. 21 were sound signals and just 2 sound marks. That one of them could be even a sound signal that was related to a church bell. The other one was regarding to a thermal bath in Stadtgarten. The clusters were formed through a two-step cluster analysis, and we observed the silhouette measure of cohesion and separation, as well as the chi-square goodness of fit to tell if the cluster was good, significant, or randomly generated. There was 2 situations. When it was significant, like in the keynote sounds, it generated like a cluster membership. When there was no significant result, it was not possible to generate the cluster membership, but even so we analyzed the data regarding to the psychoacoustic analysis. The cluster were formed by those parameters that I'm indicating here. We had 3 models. The differentiation of each model was how I classified each special feature. Like I used the classifiers for keynotes just in the keynote model and so on. Same thing for sound signal and sound mark. We had as result here, it was not possible to form clusters with just 2 observations of sound marks, so we don't have clusters for sound marks. For sound signals, it was formed 2 clusters, but they were not significant according to the chi-square goodness of it. Or it means it was generated randomly. For the keynote sounds, we had 2 clusters and they were significant. These 2 clusters were like one with regarding natural sounds, where geography, background sound, and natural sounds helped to classify these natural sounds, and they provided a positive tendency of responses for the other classifiers regarding soundscape. The second cluster was formed by mechanical sounds, where the sounds were classified as background sound and man-made sounds, and they provided a negative tendency of responses regarding to the soundscape. The part of psychoacoustic analysis, we can show here the sound signals. They were divided into sounds as indicators, sounds and society, natural sounds, and mechanical sounds. Sounds as indicators are church bell, horn, ring, reverse alarm, car beep, alarm, rescue siren. Sounds and society was a telephone, a mobile. Natural sounds, dog barking in different areas, and mechanical sounds were regarding to traffic and the squeak of a tire. Here we are showing the plots of loudness average and loudness N5 and sharpness. We can observe that the natural sounds concentrated the values in loudness average and N5, and they spread their values, or there's a greater variability in sharpness. We can also observe that the highest amplitudes, looking here the x-axis, are in mechanical sounds and sounds as indicators. The same can be observed here in the tonality plot. In the keynote sounds plot, we can see the formation of 2 clusters, and there was a situation where the reports were not fitting to these 2 clusters. That's why we have in the not applicable plot here. Sounds and societies are mainly activities that they were doing there. Sounds, natural sounds are regarding to animals, wind, water, and trees. Mechanical sounds are regarding mainly to traffic and railway, and human sounds to people talking, walking, pedestrians, kids, and voices. Here we can observe in the second cluster that was a concentration again in loudness, average, and N5 of values, and here a spread in the sharpness plot. The opposite happens for the mechanical sounds. There was a spread on loudness, average, and N5, and a concentration in sharpness. The highest amplitudes were observed in the mechanical sounds for N5. And here we see the plot of tonality, where in all clusters we observe a spread of values and a concentration in fluctuation strength and roughness. It was also observed in the second cluster, the highest amplitude for mechanical sounds, for fluctuation strength and tonality. This work aimed to define new sound sources classifiers according to Schaffer and other authors, and applied the new suggested taxonomy to perceived sound sources considered as special features in Aachen, Germany. The aim was achieved through a systematic literature review, adding qualities for the classifiers sound marks, keynote sounds, and sound signals. It was observed that really few sounds are classified as sound marks, and it was not possible to form clusters. Keynote sounds form two clusters, one of them composed by natural sounds and the other by mechanical sounds. The natural sounds provided positive quality feedback, and the mechanical sounds negative qualities. The highest amplitudes were observed in the cluster number 2 in N5 fluctuation strength and tonality. Sound signals, they provided clusters but were not significant, and the highest amplitudes were observed in sounds as indicators in N5 and tonality, and also in mechanical sounds in the N5 or loudness N5. Thank you for your attention.